The sun beats down mercilessly on the arid, alkaline hills of northern China, a landscape where survival is a daily battle against the elements. Amidst the cracked earth and shimmering heat, a lone shrub stands defiant. This is Xanthoceras sorbifolium, known to many as the yellow horn. While other vegetation withers and dies, this remarkable plant clings to the nutrient-poor soil with a massive, ancient root system that reaches deep into the heart of the earth. It is a biological marvel of endurance. Dr. Lin pushes aside a brittle, sun-bleached branch, his hands moving with practiced care, as he collects the hardy leaves for the morning extraction. He knows that within these dusty leaves lies a secret of survival perfected over millennia. Every movement is deliberate, a silent dialogue between the scientist and the sentinel of the desert, preparing to bring these ancient defenses into the light of modern inquiry. Back in the laboratory, the harsh desert sun is replaced by the sterile, cool glow of fluorescent lights. The centrifuge hums with a steady, rhythmic vibration, a mechanical heartbeat in the silence of the workspace. Dr. Lin carefully pours the vibrant green extract into a glass flask, his eyes fixed on the delicate separation of compounds. As the liquid settles, he begins the painstaking task of identification. He counts 195 distinct molecules, a vast and complex chemical arsenal forged in the heat of the hills. Triterpenoids and flavonoids appear in the analysis, each one a specialized weapon designed by nature to protect the plant from stress and disease. It is not just a mixture. It is a sophisticated library of biological solutions. Lin records every finding, knowing that even the smallest peak on the chromatograph could hold the key to a medical breakthrough. The lab is quiet, save for the hum of discovery. The investigation moves deeper into the cellular level. Lin moves to the next critical phase, testing the potent seed oil against lipid-storing cells. With a steady hand, he adds the golden oil to the culture dish, a microscopic battlefield where biology meets chemistry. Under the time-lapse camera, the world slows down. We witness the invisible struggle as the yellow horn extract begins to interact with the cells. The lipid accumulation, which previously grew unchecked, begins to falter. The expansion slows, then, remarkably, it halts altogether. It is a visual triumph of science. Lin watches the screen, his face illuminated by the data. The oil is doing more than just existing. It is actively regulating the cellular environment, proving that the resilience of the shrub can be translated into a tool for human health. Every frame of the time-lapse reinforces the plant's potential as a functional food and a powerful metabolic regulator, bridging the gap between the desert and the clinic. Lin slides a new tray of cells under the microscope, his breath catching as he prepares for the most significant test yet. The screen flickers to life, displaying a chaotic dance of inflammatory signals. But as the extract is introduced, the chaos subsides. The plant's chemical messengers are effectively blocking the inflammatory pathways, specifically targeting the critical NF-kappa B pathway with surgical precision. This is the moment of realization. They are not merely studying a desert shrub. They are decoding a highly advanced biological machine. However, despite these stunning results, Lin pauses at the data board. He is a man of science, and science demands more than just isolated victories. He points to the glaring gaps in the narrative, the missing clinical validation, and the long-term toxicity reports that remain unwritten. "We have the potential," he says quietly to his assistant, his voice echoing in the room filled with stacks of patent filings for biodiesel and functional foods. He clicks his mouse, and the room is filled with the glow of an AI-driven simulation. Complex molecular chains dance across the screen, mapping the structure-activity relationships of the remaining unknown compounds. The AI works through millions of permutations, trying to understand how this plant achieves its ancient balance. It is a digital reflection of a natural masterpiece, a symphony of carbon and oxygen that has survived for eons. The data flows like a river, revealing a map of possibilities that could redefine medicine and industry alike. As the sun finally dips below the horizon, casting long, purple shadows over the laboratory, Lin secures the heavy door. He leaves behind the glowing screens and the silent flasks, knowing that the plant's full potential is a treasure to be unlocked by the next generation of researchers and molecular data. Outside, the desert wind begins to howl, rattling the window frames with a restless energy. But in the darkness of the hills, the yellow horn remains deeply rooted and unmoving. It has survived centuries of drought and wind, and it can afford to wait a little longer. It stands as a testament to ancient resilience, a biological secret, waiting patiently for the tools of science to finally catch up to its sophisticated wisdom. The work continues, one molecule at a time, until the desert's gift is fully understood.